Hi, welcome to Sachin Study Tech. Today topic is dynamic programming. So in previous classes we had discussed using greedy method you can solve some problems. So when compared to greedy method, the dynamic programming is it can provide the optimal solution. So in greedy method may or may not be provide the optimal solution. You know already feasible solutions may or may not be a optimal solution, but if the solution is existed in any problem, it can gives the optimal solution by using dynamic programming. Later class you can discuss what is the drawback of greedy method. Now we can see what is the dynamic programming. Here the dynamic programming approach is a optimization technique. Here also it is a optimization, it is a minimization or maximization problem you can solve by using dynamic programming approach. So what is the main theme of dynamic programming approach is you can see solve a dynamic programming problem. We first write a recursive solution in way that there are overlapping subproblem in the recursion tree. So now we can discuss one example, then you can understand what is meant by subproblem and make sure that the recursive value is computed only once. This is the important point. So we store the result of the recursive calls. There are two ways to store the result. One is the top down approach, that is the memoization technique, and other is the bottom up approach, that is the tabulation. Now we can see, so these are the two characteristics of the dynamic programming. One is the optimal substructure, another one is overlapping subproblems. So optimal substructure means optimal result of the subproblem to achieve the optimal result of the bigger problem. So what are the problem is there, that problem is divided into number of subproblems, then each and every subproblem result you can store in array, then whenever you can require that subproblem result you can take that result. Okay, unnecessarily can find out the more than one time those subproblems. So what is the overlapping subproblem here? The same subproblems are solved repeatedly in different parts of the problem, referred to overlapping subproblems. So how can solve that this problem here? You can discuss one example. Now we can see example of nth Fibonacci number using top down approach. Here you can see this is the function. Static int count, initially it is 0. How many times the function is called, recursive function is called, so the count will indicates that. Now for example you can discuss one example. So for example fib of 5, here it is a top down approach. You can call n is the 5 now, so count is incremented, that is count is incremented by 1, and if n less than 0, so 5 less than 0, so condition is fail, then 5 equal to 0 no, and 5 equal to 1 no, then sum equal to fib of n minus 1 plus fib of n minus 2. So that is, you can call the function again and again, fib of n minus 1 and fib of n minus 2. So here you can see fib of n minus 1, fib of n minus 1, that is 4, and fib of n minus 2, that is 3. So here again you can call this function 4. So then 4 is not equal to 1, 4 is not equal to 0, 4 is not less than 0, then sum equal to fib of n minus 1, again you can call this the same function. So then here it is fib of 3 n minus 1, that is 3, fib of n minus 2, that is 2 here. Here also fib of 3, that is fib of n minus 2, that is fib of 2. Here it is fib of n minus 2, that is 3 minus 2, fib of 1 here. So here it is fib of 2. So again you can call the same function fib of n minus 1, that is 2 minus 1, that is 1, and fib of 2 minus 2, that is 0. Here it is 1, directly can return, if n is 1 you can return 1 here. Now here also you can find out, here also fib is 2, so fib of n minus 1, that is fib of 1 and fib of 0 here. Here also you can find out the fib of n minus 1 that is 2 and fib of n minus 2 that is 1. Here also you can find out fib of n minus 1 that is 1 and fib of n minus 2 that is 0. So you can observe one thing here. So here also you can find out the fib of 3. Here also you can find out the fib of 3. So here also you can find out the fib of 2 and 1. So this is called as a, so already we have discussed, this is the one important property here, overlapping subproblems. So what are the problem is there, recursively you can call the same problem again and again if you can solve that subproblems. But so what is the drawback here? It is the time complexity is big of 2 power n. So here also you can calculate the fib of 3. Here also you can calculate the fib of 3. So all these things you can calculate it more than once. What are the subproblems is there? That subproblem you can calculate it more than once. So that is the drawback. So how can rectify this problem? Now we can discuss fib of 1. So n is 1. So 1 equal to 1, return 1 here. It return 1. So it return 1. Here fib of 0. So that is n equal to 0, return 0 here. It return 0. And fib of 2 is, so fib of n minus 1 plus fib of n minus 2, like here you can add this subproblem result here, 1 and 0, 1 plus 0 is 1. So fib of 2 value is 1. Here the fib of 1 value is 1 and fib of 3 is 1 plus 1 that is 2. Fib of 3 is 2. Now here also you can see fib of 1. Again you can calculate the same subproblem. What are the problem we are solved here? Again you can calculate the same problem here also. So fib of 1, here it is a fib of 0 and fib of 2 is, here it is 1. So fib of 4 is 2 plus 1 that is fib of 3 here. Then here also fib of 1 it returns 1. Here the fib of 0 it returns 0. Here is a fib of 2 that is 1 plus 0 that is fib of 2 is 1 and fib of 1 it return 1 here. Fib of 3 it returns 1 plus 1 that is 2 and fib of 5 3 plus 2 that is 5. So you can see here it is. So how to calculate this Fibonacci number? Here it is. For example, here index is 0 and 1 and 2, 3, 4, 5, 6. If fib of 0 that value is 0, fib of 1 that value is 1. So you can add these two, 0 plus 1. You can add the previous number here, 0 plus 1 that is 1. You can add previous number 1 plus 1 that is 2. You can add the previous number 2 plus 1 that is 3 and 3 plus 2 that is 5 and 5 plus 3 that is 8. So you can see fib of 5 the value is 5 here. So fib of 5 the value is 5. Fib of 6 the value is 8. For example, here the fib of 7 the value is 8 plus 5 that is 13. Like that you can calculate the number, but the time complexity is 2 power n, exponential time complexity here. So that is the problem. You can reduce this time complexity by using memoization technique. So what are the results? Subproblem result is there. That subproblem result you can store it whenever you can require that subproblem solution, subproblem result. Then you directly can use that result without calculating that subproblem again and again. So you can reduce the time complexity. Now we can discuss here. Now you can see memoization technique used to reduce the time complexity. So already we have discussed in previous example, the time complexity is big of 2 power n, that is the exponential time complexity. The time complexity is reduced linear time complexity, that is big of n by so previously calculated value when needed you can store that value. So here it is a, so this is the only extra statement. This is one extra statement. Previous example, what is the difference between previous example and this example is, this is the extra statement here, extra condition here you can check. So this is the memo. So this is the memo. I can take the one array here. I can take the one array. So here it is initially the memo is initial values all are -1. You can indicate the -1. Here it is also indicate -1 and 3 and index 4 and index 5 and index 6 index 7 and index, for example, index 8. So here initially all values are -1. Now we can see fib of int n. For example, I am consider the same example here. The for example, if you want to find out fib of 4. Here also you can see memo n not equal to -1. Initially it is all are -1. So this condition is fail. Then count is incremented. Then if n, so that if n value is 4, so 4 less than 0 condition is fail. 4 equal to 0 it is not true. Then directly can fib of n minus 1 and fib of n minus 2. You can call the same function recursively here. But what is the difference we are identify here? You can see n minus 1 that is 3. Here it is n minus 1 that is fib of n minus 2. 4 minus 2 that is 2. Here also you can call the again the same function recursive call n minus 1. 3 minus 1 is 2 and fib of 3 minus 2 that is fib of 1. Here also you can call the same fib of n minus 1 that is 2 minus 1 1. Fib of here it is 0. So fib of 1 it returns 1. Okay, here also you can take that fib of, for example, here you can see fib of 1 and here fib of 0. So you can see the fib of 1 it can return fib of 1 it can return 1. So it return 1. So if fib of 1 it return 1, fib of 0 it return 0. So whenever you can return that values, you can store that values into this memoization. This is the array. Fib of 1 is 1, so we can update here fib of 1 is 1 and fib of 0 is 0. You can update here. You can see 1 plus 0 that is fib of 2 value is 1 and fib of 1. Okay, need not to calculate it again here. You can check fib of 1. So int n that is 1. So memo of 1 not equal to -1. So that is true. Memo of 1 is 1. It is not a -1. So it return memo of n. So what is the memo of n? That is the memo of 1. What is the memo of 1 value is 1. So directly can return that value without calculating same problem again and again. So that is 1 plus 1 that is 2 here. Fib of 3 is 2 and whenever you can return that fib of 3 you can update here fib of 3 is 2. Here also fib of 2 is 1. Fib of 2 is 1. Now you can see fib of 2 here, fib of 2, but already you can see fib of 2 means here n value is 2. Now memo of 2 not equal to -1. Yes, memo of 2 is not equal to -1. The condition is true. Memo of n, memo of 2 is 1, not that is not a -1. So you can return that memo of n. So what is the memo of n? Memo of 2 is 1. So directly can return that value. You can need not to can calculate this again and again here also. So here fib of 2 directly can return that value is 1. So fib of 4 value is 2 plus 1 that is 3 here. So we can update the fib of 4 value is 3. So here fib of 4 value is 3. Now so these are the memoization technique. So what are the sub problems is there? The problem is bigger problem, then the problem is divided into sub problems, but that sub problem solve only once. Okay, if more than once the same sub problem will be occurred here, then need not to solve those same problems again and again. So what are the sub problem result is there? That result will be stored in array. Whenever you can require that result, directly you can access that result from this array. Okay, need not to calculate again and again. So that's why the time complexity is reduced, that is big of n. Now here it can see bottom up approach here, fib of int n. Here it is a bottom up approach. Like here the a of 0 is 0, a of 1 is 1 and a of I equal to 2, I less than or equal to n, I plus plus. For example, fib of n, that fib of n is, for example, here it is n value is 6. N value is 6. Now the size of the array is a plus n plus 1, that is 6 plus 1, that is 7. A of 7. Now here it is a of 0, we can add it extra here, a of 1 is 1. So a of 0 value is 0, a of 1 value is, so you can see here the 0 index, this is the 1 index, it is 2 and it is 3, here it is 4 and 5, 6. Now we can see a of 0 value is 0, you can set a of 1 value is 1. Now I equal to 2, so here a of I, that is a of 2, a of 2 equal to a of 2 minus 1, a of 2 minus 1, that is a of 1. What is the a of 1 value? 1 plus a of I minus 2, so 2 minus 2, that is 0, so 1 plus 0, that value is 1, so a of 2 equal to 1. Okay, now here also you can increment I value, so then a of 3, a of 3 equal to a of 3 equal to a of 3 minus 1, that is a of 2 plus a of 3 minus 2, that is a of 1. So you know already a of 2 value, that is 1, plus a of 1 value is 1, so a of 3 value is 2. Now directly you can store here. Then a of 4, I value is incremented. Now a of 4, that is equal to a of 3 plus a of 2, a of 2, a of 3 value is 2, so a of 2 value is 1, so 2 plus 1, that is 3. So you can store here a of 4 and a of 5, a of 5, here a of 4 plus a of 3, a of 4 value is 3, here you can see, and plus a of 3 value is 2, so that is equal to 5, so a of 5 value is 5. Now we can see the a of 6, a of 6 value you can increment it up to I less than or equal to n, so n value is 6. Now I value is 6, 6 less than or equal to 6, the condition is true, a of 6 equal to a of 5, a of 5 plus a of 4, a of 5 value is 5 plus a of 4 value is 3, so a of 6 value is, a of 6 value is 8, you can see 5 plus 3 8, so 2 plus 1, that is 3, 1 plus 1, that is 2, 0 plus 1, that is 1, like that. So here also time complexity is linear time complexity big of n. In this case also it is a bottom up approach. So in previous, so here it is top down approach, it is bottom up approach. Okay, thank you for watching this video. Later you can discuss more problems by using dynamic programming approach.